Okay, we're going to work on question number 4. Find points on the curve where you have horizontal tangents or vertical tangents. And your curve here is r equals cosine plus sine theta. So to talk about first horizontal tangents, we're going to point this out that you want the derivative equal to 0. This derivative equal to 0. The derivative is dy d theta, which is really dr sine theta plus r cosine theta. At least the numerator portion, the denominator, dx d theta, is dr theta cosine theta minus r sine theta. So in order to get this first derivative equal to 0, it's a fraction. That numerator must be 0, meaning the top portion, dy d theta here, needs to be 0, while the denominator could not be 0, meaning dx d theta is not 0 here, but the numerator is. So we're going to take this equation. I write it really as r prime sine theta plus r cosine theta. This is what we're going to set equal to 0 because the derivative is a fraction. That's going to give us the locations of these horizontal tangents here. Vertical tangents is the reverse, where you set this denominator. Well, we'll take a look at that one. Let's start first with the horizontal tangents. So r prime sine theta plus r cosine theta must be 0. Remember what r is. R is cosine theta plus sine theta. So maybe we're going to pick some colors here maybe so you guys can see this a little bit better. R cosine theta. This is what we're going to use here. This is our r. Right? Cosine plus sine. Sorry. We'll substitute this in for r. R prime is really dr d theta. So we're going to differentiate cosine plus sine here. Now this derivative, because that's what r is, derivative of cosine minus sine. Derivative of sine is cosine. So I'm actually going to write this in reverse and maybe color that gold, I guess. So we're going to plug that in here. So plug those in. And like I said, I'm going to write it as cosine plus sine. I won't start it with a negative term. This is multiplied to sine theta. Since I don't have a lot of space, we'll write it down here. And that gets multiplied to cosine theta here. Don't forget to set this equal to 0. So there you go. Make sure you use your distributive property now. So cosine theta sine theta minus sine squared theta plus cosine squared theta plus cosine theta sine theta equals 0. Okay. Now, notice that you have like terms here. Cosine theta, sine theta. Cosine theta, sine theta. So I'll write this as cosine squared theta plus 2 cosine theta sine theta minus sine squared theta will equal 0. Okay. Now this is a trig equation that we have to solve. All right. So in order to solve this trig equation, we're going to have to use some identities. And the first identity is really a very, very important trig identity here. 2 sine cosine theta is sine double theta. So we do have an identity sheet that we use, right? And then what I'll say is we're going to use on the left over here what's also known as a half angle identity. Cosine squared is 1/2 plus 1/2 cosine double theta. You see, you have this double angle here. And so we have to use an identity that also gives us a double angle. And similarly, the half angle identity for sine squared is 1/2 minus 1/2 cosine double theta. So if you notice, we're just writing everything in terms of that double theta here. Now, doing some algebra, we'll notice that the 1/2 goes, well, doing algebra, let's see what happens here. Yeah, 1/2 doesn't go away, but the constant term, 1/2 plus 1/2 here, will give us 1. So you have 1. And then we'll notice that the positive 1/2 cosine double theta will cancel with the negative 1/2. Oh, I apologize. Let's go back here. We're doing a little algebra mistake here. Let's be very careful here. We're going to have to distribute. That's why this is kind of being a little weird here. Alrighty. So let's be careful. I'm going to write this down. You got 1/2. If we keep the red, that might be helpful. 1/2 plus 1/2 cosine double theta plus sine 2 theta. Remember, you're distributing that negative. That was what was happening. That's why I started to cancel this, and I said, wait a minute, but this becomes now plus 1/2 cosine double theta. This equals 0 here. So now we're okay, where the 1/2s go away, and we combine the like terms here of 1/2 cosine double theta plus 1/2 cosine double theta. You're going to get cosine double theta plus sine double theta equals 0. All right, now we're on the right track. Okay, we're on that right track here. And we can actually, let's see, sine over cosine. We can translate, and you get sine double theta. Let me do this now. Let's go back to blue, since we finished the identity work. And you guys know that sine of a double angle, or just sine of an angle equals minus cosine of the angle, means tangent of the angle is -1. Okay? Now, if you recall from trig, all students take calculus. Now, I can bring in what I do in a trig class. And I'll just bring that in here, remind people, since we're taking our time going through some details. There we go. That tangent is negative in quadrant 2 and quadrant 4. So remember, solving this trig equation, I might, let's say, use, it's double theta. I don't know, use an angle. Also let alpha be double theta. So we're really finding tangent alpha is -1. And yeah, alpha's in quadrant 2. 3 pi over 2. And alpha is in quadrant 4. I think these 3 pi over 4. If you guys recall, let's do it. Let's get every detail here. Your reference angle is always the positive quadrant 1 angle. Pi over 4. But these answers are in quadrant 2 and quadrant 4. So just remember that this reference angle of pi over 2 is the reference angle over here of pi over 2. You can look at my videos on solving trig equations for all those details. But that means alpha is going to be pi over 4. Reference angle is pi over 4, not pi over 2. 1, 2, 3. So we get 3 pi over 4, 4, 5, 7 pi over 4. These are the two solutions here for alpha. Okay? Yeah, anyway. So alpha, though, is double theta. Don't forget that. And what that'll mean is, since alpha is double theta, replace your alpha with a double theta. And solve for theta. Your first solution, theta 1, is 3 pi over 4 divided by 2, which means 3 pi over 8. The second solution is 7 pi over 4, which means, and don't forget that's divided by 2, which means the solution is 7 pi over 8. So, ladies and gentlemen, these are the two values of theta where you'll have a horizontal tangent. Okay? Two theta values, horizontal tangent. Now, they ask for points. So if I go back over here, they want points on the curve. Those are polar coordinate points. Okay, so those are locations on your curve in polar coordinates. A point in polar is r theta. So we already got theta. We need r by simply plugging it in here. So remember, there was two values of theta for horizontal tangent. 3 pi over 8, 7 pi over 8. Okay? 3 pi over 8, 7 pi over 8. So here, essentially, what we're going to say is this. The first point, we need some space somewhere here. Let me write it on top, maybe. Okay. we can say cosine 3 pi over 8 plus sine 3 pi over 8, comma, the angle 3 pi over 8. So here's your first location, and that happens when theta really is 3 pi over 8. Here's your first solution. Okay. Second solution, since we're looking at the picture here, a 7 pi over 8 will say the same thing. Cosine 7 pi over 8 plus sine 7 pi over 8, comma, 7 pi over 8. So these are the points on the curve where you will have horizontal tangents. Okay. Now, let's take a look really quick here. Cosine 3 pi over 8. I'm going to take a look. 3 pi divided by 8 plus sine 3 pi divided by 8. Yeah. All right. So here's what I want to remark here. Let me go to Desmos for you guys here. I'm going to try to take a look at this. So I'm going to describe this here as R. Okay, and I think that curve was, well, I guess it doesn't matter what color. Color it blue. Remember, 3 pi over 8. So I'm going to kind of describe this in rectangular coordinate system because that's a little bit easier to graph a line in Desmos. You know, this isn't the equation, the polar form, but it is the equivalent rectangular coordinate form. I want to show you something here. Okay, so here's what I'm trying to remark about. What we should know is a horizontal tangent, yes, is at top, on top over there. So where your circle is. And then y equals tangent of a 7 pi divided by 8 x. Okay. You should see down here, this is where you have the second horizontal tangent. So what I'm trying to show people is really this. This location, you have the horizontal tangent. Al tan. Over here, the second horizontal tangent. These are the 2 points we just found in polar coordinates. Okay, these are the ones we just located here. Now, the second part is the vertical tangents, and I'll do a remark here. You can see over here, we're going to look for the polar coordinates where you have a vertical tangent line. And so you're going to see this in circles here. You got 2 horizontal tangents, 2 vertical tangents on a circle. And let's make sure this thing is nice and vertical. So I'm going to go through some of the details so you guys can see that there. But we're going to go through the same process again. These are our horizontal tangents. Okay. And let's do something like, if we can, copy all this or bring it down. Because there's our conclusion. They also want to discuss vertical tangents. So for vertical tangents, for your derivative here, if you recall, we're going to need to set the denominator equal to 0 now. So we're going to focus on the vertical tangents. And let me emphasize with color. Your denominator in your derivative for dy dx will be 0. This is for vertical tangents now. And that just means dx d theta has to be 0, but dy d theta can't be 0. So this is going to be described now as r prime cosine theta minus r sine theta will give you a nice 0. So for the vertical tangents, r prime cosine theta minus r sine theta is 0. Go back and double check. Yeah, r prime cosine minus r sine. R is the same r we use, cosine plus sine. So replace your r with cosine plus sine right in here. R prime, and I think we use purple, if I recall. No, gold is cosine minus sine. So it's cosine minus sine. Okay. So you have cosine theta minus sine theta times cosine theta minus r, not minus r, but minus cosine theta plus sine theta times sine theta equals 0. Okay, let's do the algebra here. So we're going to end up with cosine squared theta minus sine theta cosine theta. Let's be careful here. This is going to be a minus cosine. I'm going to put the sine before cosine. Okay, we're using that distributive property, and then that'll be a minus sine squared theta. You get equal to 0. So we get a very similar question here, or a very similar trig equation to solve. Again, this is the trig equation. It looks similar. Okay, so how do we solve this? We're going to use the same procedure using identities, 2 sine theta cosine theta is sine double theta. Cosine squared theta is simply 1/2 plus 1/2 cosine double theta, your half angle identity. Sine squared theta is also 1/2, but that would be now minus 1/2 cosine double theta here. So we'll end up with 1/2 plus 1/2 cosine double theta minus sine double theta. We're going to subtract here, and we end up with negative 1/2 plus 1/2 cosine double theta will equal 0. Now, similarly, your 1/2s go away. And now we get 1/2 cosine double theta plus another 1/2. That's going to be cosine double theta minus sine double theta equals 0. And again, solve for sine double theta. This is the classic representation of tangent double theta equal to 1. And again, solving your trig equation, I guess I'll let theta be, we're going to say let alpha be double theta. So you really have, again, tangent of alpha being positive 1. Now, remember, if I bring that work in from a trig course, we know where tangent alpha is going to be positive 1. All students take calculus, right? That's going to be in quadrant 1 with your reference angle. Let me do this. It's a quadrant 1, quadrant 4 solution. So if people remember from trig, again, your reference angle here is pi over 4. And in quadrant 1, your reference angle is the angle. We're calling that alpha, by the way. So the first solution for alpha is pi over 4. And the quadrant 3 solution is 5 pi over 4. This is where tangent's positive. So these are your two solutions. But don't forget, alpha is double theta. So 2 theta becomes pi over 4, or theta will be pi over 8. 2 theta, pi over 4, theta becomes 5 pi over 8. These are your two solutions here. Pi over 8 and 5 pi over 8. But your R is cosine theta plus sine theta. So when they say points, they just want the polar coordinate points. So I'm going to do the same thing as I did earlier. Your first solution of pi over 8, what that means is the polar version is cosine pi over 8 plus sine pi over 8 angles pi over 8. Your second solution of 5 pi over 8 gives you a polar of cosine pi over 8 plus sine 5 pi over 8 comma 5 pi over 8. So here's going to be your location, your points on this curve where you have vertical tangents. Okay, pi over 8, 5 pi over 8. Now, going back to the picture here, this angle this is pi over 8. Over here, We do this array. 5 pi over 8 for theta. So you can even go to Desmos if you like and verify that, pi over 8 and 5 pi over 8. You can say, let's get rid of these here. Y equals the Cartesian coordinate version, since Desmos doesn't describe, believe it or not, it's not as easy to do in Desmos, so I'm going to stick with this Cartesian coordinate, y equals a function of 8. So there you go. There's your vertical tangent on the right side. And then y equals tangent again, 5 pi divided by 8x. And let's change that. I guess we could change that to red too. And sure enough, it's exactly what I'm saying here. Okay? So yes, those are the locations of your vertical tangents. This is what we're describing, but let me just remark, those are the angles that I just represented here. Okay, in polar form, just so you guys know. Here's the location, here's the location. I can get rid of these. So sure enough, that is consistent with what we've gotten. So that's the answer for number 4. Okay. Horizontal and vertical tangents. As you guys see, it's a trig equation. Scrolling down now all the way to number 8 here. R squared sine double theta. They also want points, locations where you have the horizontal tangent and vertical tangents. So again, if I go back, let me try to copy this. See if I can do this kind of cleanly. Duplicate that. Okay. There we go. So for horizontal tangents, where are we at? We need r prime sine theta plus r cosine theta equal to 0. R prime sine theta plus r cosine theta equal to 0. We need dr d theta. We have r squared is sine 2 theta here. We got your infinity sign. So we need r prime. Remember, r prime is dr d theta. So what you're going to need to do to find r prime, since you are given r squared, you're going to have to use implicit differentiation. Implicit. So I'm going to differentiate the r squared. So implicit differentiation gives me dr, 2dr, times dr d theta. There's going to be our r prime. Now the derivative of sine is cosine 2 theta, but by chain rule, and you're really using chain rule on both sides, we get 2. So it looks like I can cancel my 2's here. And we can simply say that dr d theta will become cosine double theta over r. So I just solved for dr d theta, or r prime that we're looking for is cosine double theta over r. Okay. And I think that was gold. It's going to go right in here. Okay? Now, even though the equation they give us is r squared is sine 2 theta, I'm going to leave this equation in terms of r. Let me bring this part down now, or at least copy it. Ah. All right, let's bring it down. So plugging that part in, we have what? Cosine double theta over r sine theta plus r cosine theta equals 0. All right, we're going to need to do some algebra now. What I'm going to do is multiply the top and bottom by r, so I have the common denominator here of r, so I can add. So sine double theta, well, let me go back, cosine double theta, sine double theta plus r squared cosine theta over r equals 0. Okay. Now, why that's nice is because if I go back, recall that r squared is actually sine double theta. This is the equation of your Lemniscate. Sine double theta for r squared. So I can replace this r squared with my sine double theta. And what you end up with is cosine double theta sine double theta cosine theta over r should be 0. And there's a typo here. This should be theta. Okay? So I added there, and I shouldn't have had. Remember? There's a sine theta here. It's not double theta. Come on. Let me remind you. That's sine double theta. Or sine theta. There we go. Okay? Just to kind of be clear now, since we're trying to go over this carefully and delicately. What you're looking at here is a fraction equal to 0, which implies your numerator must be 0. So I get cosine double theta sine theta, and there should be a plus here, plus sine double theta cosine theta is going to be 0. Okay. What you now see here is, if you recall your sum and difference formulas, where if you have cosine double theta, sine theta plus cosine double theta sine theta, okay, this becomes, I believe, sine 3 theta will be 0. Okay. So now again, we have a nice trig equation. I'm going to let alpha be 3 theta. So this now becomes sine of alpha equals 0. Well, that means alpha is 0. Alpha is pi. And alpha is 2 pi. All right. Okay, so that's for your sine curve. But again, don't forget, this is really 3 theta. So what that means now is 3 theta is 0. 3 theta is pi. And 3 theta is 2 pi. Okay. Now this means theta is 0. Theta is pi over 3. And theta would be 2 pi over 3. But I want to remark about something here for this lemniscate. When you're going to graph a lemniscate, you got to go back here to y equals sine double theta. And the period is 2 pi over 2, which is pi. Your interval of one cycle is 0 to pi. So how we start to graph lemniscates, let's see if this means anything for us. I think we have to look at the domain here. Okay. So for this first portion, we have 0 to pi over 2 for that lemniscate. That's really looking at this first portion. But if we continue with the second cycle of sine, if I continue there, and I can't, you can have pi to 2 pi. Five pi over 4, 6 pi over 4, 3 pi over 2, 7 pi over 4. The second portion is essentially over here. So it goes from pi, 5 pi over 4. Three pi over 2. Anyway, I'm just looking at this picture here for this. All right. So if I'm going to look at these values, 0 pi over 3, 2 pi over 3, right? This angle is not in the domain of the lemniscate. So far, we're going to have a point here, a point here, and a point over here. These are the locations of your horizontal tangents here. Okay, so let me bring this in Desmos and remind people. I'm going to put y equals sine double theta. That's going to be, we're going to look at from 0 to 2 pi. Okay. Let me bring this in. So I'm just going to look at the graph here, put it in green. This is where 0 is. I believe that's pi over 2. This is pi. 2 pi. 3 pi over 2. And again, this value of 2 pi over 3 is not in your domain of the lemniscate because that's going to be 120 degrees. It's somewhere over here. Because this is really an r squared axis. So the domain of r squared, or the angles, are right in here for r squared. Anyway, so we're going to have to adjust this to some degree. And let me remark here, 0 pi over 3. Over here, this would be theta equals 0. Theta equals pi over 3. This is the angle. But you're also going through the opposite side over here. And that differs by pi is what I'm saying. So the second angle we can take pi over 3 plus pi, and this will be 3 over 3, so that's going to become 4 pi over 3. There you go. See what happened here. There we go. 4 pi over 3. There it is. So you're looking back at the book and go, hey, where did they get the 4 pi over 3? That didn't solve the equation. Well, it actually does, but I would have to continue with other values of where sine of alpha equals 0 in general, meaning the general solution for alpha as a sequence is really n pi. N is an integer, which means the theta version is really n pi over 3, where n is an integer value. So there are other solutions to this in general, and that's coming into play here. So I just want to remark that this is where these are your solutions here. These are your 3 solutions if we were to extend to work with this in general. Okay. And so points on the curve need to be of the form r and theta. You have r squared. So since r squared is sine, was it 3 theta? R squared is what? 2 theta. So since r squared is 2 theta by the square root formula, r will be plus or minus the square root of sine double theta. Now your radius values are going to be positive here. Okay. And so as a solution in terms of points, we could simply say, well, that's the square root of sine 2 times 0. 0. This is your angle, theta being 0. Okay. And really what that means is this point's going to be 0, 0. So when theta is 0. When theta is pi over 3 now, what you'll see as a point, square root sine, we'll leave it as 2 pi over 3. How about if we just, we'll leave it as 2 pi over 3. Okay. Comma, angle is pi over 3. Here's your next point. And then when theta is 4 pi over 3, square root sine 4 pi over 3, comma, 4 pi over 3. These are your points. Anyway. Went over all of this in very, very intricate detail for you guys. Okay? Now, if you said, what about vertical tangents now, right? Because these are the location of horizontal tangents. What about vertical tangents? Well, you're going to have to do the same thing. Go back again, but this time for vertical tangents, you're going to look at the equation down here. R prime cosine theta minus r sine theta is 0. I'll just write it down. R prime cosine theta minus r sine theta equals 0. Now, r prime again, if we go back and remember, we solved for r prime already. It's cosine double theta over r. Cosine double theta over r. And we're just going to leave this for r again. So we'll have to solve a trig equation here and do some algebra here. All right. Okay. Cosine double theta over r, cosine theta minus r, sine theta equals 0. So we're going to multiply the top and bottom by r. We'll get cosine double theta, cosine theta. This is over r minus r squared, sine theta over r equals your 0. So you get cosine double theta cosine theta minus r squared sine theta over r equals 0. And you'll end up with, well, this implies, by the way, since you have a fraction equal to 0, your numerator must be 0. Don't forget what r squared is. I believe that's sine double theta. And come on. Cosine double theta, cosine theta minus sine double theta, sine theta equals 0. Now, by your sum and difference formulas again, sum and difference formulas. This becomes cosine 3 theta is 0. We're going to let alpha be 3 theta. So we get cosine of alpha is 0. Now, where is cosine 0? Happens when alpha equals what? Pi over 2. And alpha is 3 pi over 2. So since alpha is 3 theta, we get 3 theta is pi over 2. 3 theta is 3 pi over 2 divided by 3. Hold on. Let's solve for theta. Theta is pi over 6. Theta is 3 pi over 2 divided by 3, which would be pi over 2. Pi over 6 and pi over 2. So let's be careful now again. Let's go back to the domain of your lemniscate. Okay, so we're going to say these are the two answers. But if I go back to the domain of the lemniscate, yeah, pi over 6, pi over 2. Let's go back. We have a vertical tangent over here. It's pi over 6. You're going to have another vertical tangent in the opposite quadrant here from your picture. And then that'll differ by an angle pi. So let's write this down. This happens where theta is pi over 6. Theta is pi over 6 plus pi, or your second angle is going to be 7 pi over 6 here. Okay, so these are the two locations where you have your vertical tangent now. But you said, wait a minute, what about 90 degrees here for theta? Well, when theta is 90 degrees, you're talking about really the origin. Now remember what we say here for vertical tangents. dy d theta can't be 0 here. This is going to be an important detail. So we're going to have to throw that value out for pi over 2. Because we can't have both of those derivatives be 0 here. So this is the second solution. If we were to go further in sequential form, we'll get a whole bunch of other values of theta. But you have to check to see if both derivatives are 0. So here's going to be your final answer. R, again, is the square root of sine 2 theta. So we have to write things as r theta now. So square root, let's write this in black. Square root of sine 2 pi over 6, comma, pi over 6. This is going to be your first solution. And then you got square root of sine 7 pi over 6. And there's a 2, I believe. So let's be careful. 2 times that 7 pi over 6, comma, 7 pi over 6. So you can simplify this to pi over 3. And this would be 7 pi over 3 now. This is where you have vertical tangents. And, you might be able to include 0 as well. So we can include 0. 0, 0, I believe. Anyway. So this is how we're going to go through this demonstration. I hope you guys enjoyed this. I'll send it to you. Take care. I went through this in great pains and great detail.